equations with you. So I'm going to give you one more like this just to do yourself. Okay. So if I write down 5x minus 4y equals 40, what form of my equation is that?
Standard.
So this is in standard form. Is the gradient 5, Mackay? No? Okay. Maisha, what do you think the gradient's going to be? You said something yesterday, and then you did guess. I'm just checking to see whether you were guessing or whether you were knowledgeable. Would anyone like to predict what they think the gradient is going to be? No, right, let's go. Let's just work it out and let's see whether we can figure it out.
I think it's going to be 2.
You think it's going to be 2, do you? I would like you to write it in gradient intercept form, please. Go for it. First step, there are many, but the first one I would do would be to...
Isolate the
I want to get... Well, yeah, I could leave the negative 4y if I want. That isn't the way I would do it. Right, but you can. It's fine. We'll end up at the same answer. What I always get, if I want y on its own, I don't want negative y. So I'm going to add the 4y first. Now, you don't have to, okay? So I'm actually going to do 5x, subtract 4y, and I'm going to add 4y. That means I've got to add it to the other side as well. So this cancels out, and I'm left with 5x equals 40 plus 4y. Now, if I had instead done subtract 5x, I could have done 5x minus 5x minus 4y is 40 minus 5x. That gets rid, and I'm left with negative 4y is 40 minus 5x. So you'll notice how probably the right-hand side got me nearly where I want to be quicker. But the difference with the right-hand side one is that I've got more negatives. But I think the majority of you, did you do that way around?
No.
No? Did you do this way? Okay. One important reason for doing this way round, Safia, is because people tend to forget the negative. They just cross out the 5x by subtracting it, and then this negative here miraculously disappears. Okay? Because what is 5x subtract 5x? It's not nothing, it's... No? It's sort of nothing, but we actually say 0. So it should be 0 subtract 4y, or just negative 4y. 0 subtract 4y is negative 4y. Or what would be negative subtract 8? Okay. All right, so I'm going to carry on from this route. So my next option is I'm going to now subtract the 40. Okay, so I now end up with 5x subtract 40 equals, now I've got positive 4y. Over here, I would have divided by negative 4 and ended up with y is over negative 4. Okay? This one I would have divided by 4. Now, I hope I'm not confusing you by doing it both ways, but hopefully you're picking up on whichever way you did. So I end up with 5x subtract 40 divided by 4 equals y, or I end up with y equals 40 minus 5x divided by minus 4. All right, both of them are equivalent, they're the same, but one's slightly messier than the other. All right? We try not to have negative numbers as the denominator on a fraction. Now that leaves me with, what is the gradient? So a lot of you went straight to splitting this up and saying it's 5 divided by 4x subtract 10. Okay, this one would have been 40 divided by negative 4 is negative 10, and negative 5 divided by negative 4 is positive 5 over 4x. Have we got exactly the same thing? We do. Okay. What is the gradient? Good. What is the grade? No. What is the gradient not?
10.
5 over 4x.
3? It's not though. I just say it.
The gradient is the change that is applied, and that is 5 divided by 4. Guys, it's important. I will mark you wrong if you add an x, and there is a reason for that. As you start looking at gradients of curves, where the gradient changes as you go round the curve, the gradient is then not a constant, and so it's not a number, it's another expression. So 5 over 4x gives me a gradient that is changing with every x. Does that make sense? Okay? So we have a linear relationship which shows constant change. Therefore, our gradient is constant, which means it must be a number. No, not a variable. It's constant. So it's 5 divided by 4. Give me a situation where that would apply. A gradient 5 divided by 4. What does it mean? Give me any situation you like. Nick again, he's good at these. Anything you want.
For every 5 pieces of pizza, what? I don't know.
Sort of, but we say it in a different way. Go on.
Every 5.
We're actually saying it the wrong way round.
Every
Every
second,
Every 4 seconds.
the pool gets filled up by 5.
Every 4 seconds, there is 5 more litres.
So where's that
Every
in something?
4 people, I need 5 pizzas. So we can say it, so it does work, right? So yeah, what does the negative 10 mean? So if we're in a pool, every 4 seconds we add 5 litres. Where were we at the start? What's the initial condition?
Negative 10.
Negative 10. And what might that mean?
Someone jumped
Negative
in.
amount of water.
No,
There's a point and you're under it.
Good.
Yeah, you're below surface.
It doesn't mean we have negative what it means wherever we start from, we're 10 litres below that point. So remember, it's called the initial condition. The initial condition does not have to be 0. Okay? All right. Can I give you one more like that, and then I want to move on to a couple of different ones that you might find harder. Right? So let's do 7y subtract 6x equals 42. Let's go through this one. Then there's another one I want to go through, and then you can go and work on at your own pace. So with this one again, what I'm trying to get it over to you is I don't want you to try and memorize a certain set of steps that you always do. Okay? You should be looking at what you have and the most efficient and effective way of getting to where you want to be. All right? So, just because in the last one, what did I do in the last one? I moved the y, I added 4y. Well, the only reason I added 4y was because I don't want y to be negative. That's my choice. But that doesn't mean you always move the y. What's my ultimate goal? Is to have a single positive y, yes? So, with this question, y is already positive. So I definitely don't want to be subtracting it, right? So the first step really that I want to do is to actually add 6x, because I want to leave the 7y on its own, which means on this side I've also got to add the 6x. So that gets rid of that and leaves me with 7y is 42 add 6x. Okay? Okay. The next step is I've got too many y's. I've got 7 of them and I only want 1. So we have to divide by 7. Okay? So I divide this side by 7. So I end up with 42 divided by 7 is 6, but I've still got 6 divided by 7x. What's the gradient?
6 over 7.
6 divided by 7. Okay? Alright. Now, I want to have a look at one more with you before I let you carry on, because I think fractions are going to throw you, and they don't need to. Alright, so I'm going to explain how to do it. So if you have a look at question 1G, right? So 1G on page 128, we have this time 3 divided by 2x, subtract 1/3 of y, and that equals 0. Okay? So I want that in y equals mx plus c form. I want it in gradient intercept form. Now remember, what is the goal of the change? So isolate the y and have how many y's?
1.
1. That's the first thing I should think about doing. How many y's do I have?
1/3.
A third of 1. Yeah? I have a third of 1. How can I make a third of 1 1 times by 3? Good. So I'm actually going to multiply everything by 3. Okay, everything. So I have to multiply that by 3, this by 3, and this by 3. Okay? Now what does that do? Well, what is 3/2 of x times 3?
6 over 6. 9 over 6. 1.
So this is where we need to go back to our basic. Shh. This is where we need to go back to our basics of fractions that we have done, and you seem to be forgetting. Please don't use your calculator. We don't need to. Okay. I would say to you, you need to visualize fractions. What does 3/2 look like? You've already said an alternative form. Not.
6.
Oh, you said 4.5. I thought you said 1.5. Yeah? 1.5. 3 divided by 2, 3/2 is 1. So that would be, if I think of it as cakes, 1 cake and half a cake, or 3/2 of cake, yeah? If I multiply that physical 3/2 of cake, if I multiply that by 3, what do I have?
1/2. Like 1 and then you 6 whole. 1 over 3 over 2. 1/3.
You're not thinking about what I'm saying to you. You're just trying to randomly come up with stuff. Think in your head, picture 3 halves of cakes. If you want, half a half a half.
Yes.
Right? Don't try and simplify. Just say, what does that look like if I tell you to multiply that picture by 3?
Oh,
So
1, 2, 3.
6 of them. I mean 9 of them.
There's 9.
9 halves. I have 9 halves of x. Okay? Which actually, Michael was correct if he did say what I heard him say second time. What is 9 halves? 4 and 1 half. That's what I'm saying. This is what you said. But do you see, tonight, this is important. This is really, really important. You should not be getting towards the end of M3 still telling me that 3 divided by 2 times 3 is 9 divided by 6. You should not be telling me that. If you are, you've missed something. That's a big gap. Please don't laugh about it. You should be trying to sort of... Why is 3 halves times 3 not 9 divided by 6?
Because it's 3 over 2 times 3 over 1, which is 2 and which is 9 over 2.
Okay, but how does 9/6 compare to 3 halves? It's exactly the same number. They are equivalent fractions. Like 1/2 is the same as 2/4 is the same as 4/8. 3 halves is the same as 9/6. They're the same thing. That is not having 3 lots of it. All right? You must appreciate that if I want to find an equivalent fraction, if I do 3 divided by 2 and I multiply top and bottom by 3, I just get the same fraction but in an equivalent form. You remember doing that, yeah? If I multiply it by 3, that is different. You have to think about that, all right? Especially, look, that is a skill that we're expecting you to have at this stage. Now we're on to algebra and things. Right, you must try and remember that. So then the question is, if I do 1/3 times 3, what is it? 3 over 3, isn't it? 3 times 1 over 3. And 3 over 3 is? 1. So I then get, subtract 1y. I said 1, yeah. And what is 0 times 3?
0.
0. Okay? Okay. Now what do I do?
You got 9 over 2.
What's my target?
Isolate y.
And make it... We've got 1. Isolate it, put it on itself, make it positive. So I have negative y, so I need to add y. If I add y, I get...
9 over 2x.
Okay. All right. What's the gradient? What's the initial condition? 0. Good. There's a plus 0, which means the initial condition is 0. So this would be like the pool is filling up 9 litres every 2 minutes and it starts at 0. Okay? So that's an important one. Can I ask you to go and scrub up on your fractions, please? Be ready for that.